So hey everyone, thanks for joining us this morning. I'm here with Beto to talk a little bit about the preset cloud integration with DBT Core. I'm Sharisham and I'm a DevRel engineer here at Preset. I'll let Beto introduce himself.
Yeah, hi everyone. My name is Beto. I'm a staff engineer at Preset. I've been working with Superset for 5 years now. Yeah, I'm excited to be here.
Cool. So we'll just talk a little bit about what Preset is first. What Superset is first. So Superset is a modern open source BI platform that works with nearly any SQL speaking data engine. It offers a large diversity of charts to create dashboards to visualize your data. And there are typically two main workflows within Superset. The first being Explore, which provides you with a no-code chart builder interface. So Superset will generate queries on the user's behalf via SQL Alchemy. And typically the people using this workflow will be your data explorers and consumers, or just in general, those looking to gain insight from your data without having to be too technical. In this case, like really writing SQL. The other workflow is going to be supported through a SQL Lab, which provides a full SQL IDE, and the Superset users themselves will create these queries. The queries will remain untouched by the Superset or preset backend. And then the queries will run against the target database that Superset is connected to. This workflow is going to be typically more used by your data engineers, data scientists, or more technical data consumers and explorers like analytics engineers, for example. And so what is Preset? Preset Cloud is a multi-workspace cloud-hosted superset with all of the capabilities of Superset, and it can layer on a SOC 2 compliance with end-user documentation available. And it also provides certain controls like a row-based access control and single sign-on, as well as access to enterprise support. And we're in the process of having an embedded SDK, which is still in beta. And Preset Managed Private Cloud is Preset's BI platform for your AWS private cloud with all the same capabilities as Preset Cloud, along with additional enterprise support. So now, what is DBT? DBT is a data transformation tool that lets teams quickly and collaboratively deploy analytics code following software engineering best practices. Things like modularity, portability, CI/CD, and documentation. And it makes it much easier for those who know SQL to build production quality data pipelines. And how does DBT really do this for you? DBT lets you version control all of your data models. You can deploy safely using dev environments, and Git-enabled version control allows for collaboration and easy return to previous states if necessary. It'll also allow you to test and document every model prior to production. And DBT will dynamically generate documentation that you can share with all your data stakeholders. And we're going to see an example of this today too. And when it comes to development, you can develop all of your data models in DBT easily by writing modular SQL models with select statements and using a DBT reference function, which allows you to reference other DBT models within the same project, which really puts the brunt of handling dependency management onto DBT itself. So with that, I'm going to pass it to Beto to explain a little bit more about how the integration itself works.
Yeah, so what I want to talk about is we built tooling to synchronize your DBT assets to Preset Cloud or to a Superset instance. So it can be a Preset workspace, a standalone Superset instance. And the reason we did that is you get the best of both worlds, right? You can explore data that is built and managed by DBT. So it's data you can trust, it's data that is like certified, and then you can build atop on of those models, your DBT models on Superset. You can create new data sets, you can add metrics. So you have like a really solid foundation on your data infrastructure that you can start using in Superset. What we did here, we have an open source CLI. I have the link here for the GitHub repo. And the CLI, it's basically allows you to interact with both Preset and your Preset workspaces, so your Superset instances that are running in Preset. and allows you to interact with those instances, to run SQL, to synchronize your DBT models and metrics to preset, to synchronize. I'm going to talk a little bit about this towards the end, but you can manage also your dashboards, your charts, everything in source control, and you can synchronize that to a workspace or to multiple workspaces. And even though this tool was built for preset, it works with standalone Superset installation. So if you're running Superset, you can, every time you see preset CLI Superset in these examples, you can just use Superset CLI instead. And this is useful if you want to move data either from, if you're running a standalone Superset, you want to move to preset, you can do that using this tool. And if you're a preset customer, you want to leave, you also can use the tool to do that, which is one of the advantages of using open source commercially, is there's no vendor lock-in, right? So the repo is open, it's public, and it has all the information, like how do you authenticate to get a token so you can interact with the preset manager, how to run SQL, and it explains basically like everything you can do. You can run SQL interactively or programmatically. You can export assets, like I mentioned, from one workspace to another. Going back to the presentation. So the way this works, like for the DBT preset cloud synchronization, this is basically what you do. So like I said, it's a command line application. You can specify, like Srisham said, with preset, preset will give you multiple workspaces. So you can have multiple instances of a superset running. And when you synchronize DBT to a workspace, you can specify a workspace here. If you don't specify one, you'll be prompted to choose one interactively. And you can even choose multiple workspaces. So if you want to have copy, you could do that. And basically what we're doing here, so we're specifying a workspace. We're saying we want to use the sync dbt command. And we need to pass the manifest JSON for DBT. So I think Srisham is going to show this better, but manifest JSON is the file in DBT that has all the information about your project. It has your models, it has your metrics, it has your sources. That's just a big JSON file. And the way the synchronization works, it's pretty simple. We just need to parse that JSON file, extract models, extract the dependencies, and then we can use the Superset API to recreate those models and those metrics inside Superset. An interesting thing about this integration is it's bidirectional. So DBT has a concept of exposures. Srisham is also going to show this, but an exposure is basically where your data is being exposed to the world. So if you have a DBT model and somebody builds a dashboard using that data, you want to know that that model is being used somewhere, it's being exposed somewhere, so you don't want to delete that model. So with the CLI, you can generate models in Superset, build dashboards on top of them, and then synchronize back so that DBT is aware of where the data is being used in Superset. So this is basically how it works. On the left here, we have like a DBT project. This is the Jaffle shop example. If you follow the DBT tutorial, this is the example they have. We have a few sources there, customers, orders, and what the command will do is basically like recreate those models and those sources in Superset as certified datasets. And the DBT has this new concept of metrics. If you have any metrics defined, they will also be created inside the datasets. So here we have a metric inside customers called new customers. This is just an example, but you can recreate these metrics in Superset, and then you can explore them. You can apply different time grains. You can group by dimensions and all kind of different explorations you want to do. Yeah, I'll pass it back to Srisham now for a demo.
So yeah, what Beto showed was with the Jaffa Shop example, which is DBT's like tutorial sort of starter project. And what we thought would be interesting would be to see it in the case of a real data set with some real transformations and a full DBT project. So that's what I'll be sharing today. So the first thing I'm going to show is the dashboard that we used all of this data, and just run through what the data is. So essentially, we created a dashboard here to visualize city bike data, which is the primary bike sharing system in New York for anyone who's not familiar. And we have various metrics being calculated where we can see how many members are riding, or the total number of members riding, the number of non-subscribers just checking out a bike and taking it for a spin. We have, and we can just see those sort of member versus non-member statistics here. We also just have more general station statistics summary. where we can basically group and we were trying to see what the most popular stations were between subscribers and non-subscribers, and also just this little map showing what some of the most popular start and end locations were. And all of this data lives within our Snowflake warehouse here. And one of the coolest features about dbt is that what it does is it transforms the data exactly where it lives. So all of this raw data that dashboard was built off of comes from this one city bike trip data warehouse. What dbt does is it actually creates a new analytics warehouse for you where it applies all of these transformations. And I'll put up a link to this repo where I was managing all of the code, or I'll share that later when I can find the chat. But this is where we can actually see the different models and everything that we sort of created. So I'll switch back to my terminal to show that a little better. So within the dbt project itself, you can ignore those, but we have this models directory where we've created our derived models, our best, which is the live data feed that the bike sharing system uses, as well as a historical model directory. And what these contain are basically the SQL or the logic that we would use to derive some of our data sets. So going back here, we can see the data sets that we created from dbt, where it was basically a historic ride history table, a station status, which we were also pulling from a different feed, total rides by status, which was a pre-calculated metric. And you can see the SQL that I won't go too much into the modeling part of it itself. And you can always go back and reference this later if you want to check it out or recreate this project. But all of these models are created using dbt, and I can show that by actually just running dbt once. And we should be able to see all of these models rebuild. The 6 models that we talked about, or we showed, where we had a bunch in derived, we had a couple in historical, and we had 1 in GBFS. And we can actually see in Snowflake itself. So whatever warehouse or database you use, that's going to be up to you. The connection itself is defined within a profiles.yaml file, which I won't open up and show here, but because it contains the credentials to my Snowflake warehouse. But essentially, dbt looks for a hidden directory that contains this file for you, a profiles.yaml file, which is where you would specify your database specific credentials. But going back here, we can actually see that dbt is running and rebuilding all of these models for us. And so the next thing that we can do is go back to the dashboard. And what we're interested in seeing is how these dashboards connect back to our data. So the thing we also talked about, which was the dynamic doc generation. Once you've sort of run this, once you've run all of your models, dbt is ready to kind of serve these docs to you. So what we can do is, it's a simple command, dbt docs generate. And once that runs, we can see that most of our models are good to go. The one thing we do need to do before, if we want to see all of this within our preset workspace though, is run the preset CLI command to sort of sync all of these dbt assets that we have back into preset. So I'll break down what this command is. So as Beto kind of talked about it already, the workspace that we're targeting is the workspace that this dashboard lives in. And that's what this URL is. The superset sync dbt command specifies where this manifest.json file is being created, which was why I reran the docs generate and reran the model itself to get a most up-to-date manifest for this preset CLI command to use. The project itself is also specified in my profiles.yaml as well as my dbt projects.yaml file, which again, you should be able to go right into this repo and you can see the specifics of the dbt project itself. It looks for this specific project file and directory, and then it knows whether or not, or what type of models to build for you. That's what those configurations were. Target analytics is, it tells you where dbt is actually going to build all of these. So Like I showed before, the database that DBT created for us in our warehouse was this analytics directory, and that's why that's our target. Import DB in this case, so Beto mentioned that this is back and forth between preset and DBT. If you have a data set defined in DBT that's not in preset yet, the import DB command essentially will tell preset to create this data set for you and make it available. It is an idempotent command though, so if these data sets are already in there, you should have no issues. You will know ahead of time and it will just simply refresh it or ignore it. Exposures is a little bit about, so Beto did mention it, but exposures make it possible to define and describe downstream uses of your DBT project. In this case, our dashboard and our chart. So by defining these exposures, we can actually run, test, and list all of these resources and sort of feed them into this exposure file so that the auto-generated documentation takes them into account, which is what we'll see after we run this. So we can see that it found the existing databases. So I can show you what that looks like within preset itself. So if I just go straight into preset and log in here. This was the workspace that we specifically wanted to target. We can actually see the data sets. We can see the database itself, which was the bike_dbt_demo analytics. And we can also see the data sets that got linked because we can see the database that it actually connects to. These were all 18 hours ago because for the sake of the demo, we had to make sure that everything was operational. But as we mentioned, this import DB flag, if I were to create a new model here and sort of rerun DBT and I reran this again, this command would put that data set into a preset available to be used for visualization after. So now the one thing I'm going to do is just rerun docs generate in case this changed anything, but I don't believe that that is the case here before I run the serve command so we can actually see the lineage of everything. So what DBT docs serve does is it essentially opens up a local host website for you with your lineage documentation. And so this should be a similar view to what Beto just showed with the Jaffle Shop example. And if we were to look into our lineage graph, we can actually see this was how each of these charts are being built. So let me pull this out to the side so we can see it compared to the dashboard a little better. And we can actually see each of these. So this was a total city bike member rides. We should see that within our lineage chart here, where we can see that it was being created off of this member trips model, which was also a DBT model that we created, which was simply a filter on the ride history just based on your membership status. And one more time, I don't want to go too much into the SQL itself of the modeling because that's not what we're here to see, but you can go in and you can check some of these derived data sets out. And you can see it's a pretty simple, we're just pre-filtering and creating this data set ahead of time. And the important thing to note is these orange nodes that you see these are specifically the exposures for DBT. DBT in your lineage graphs and documentation will always show these exposures as these orange nodes. And I think Beto will talk a little bit more about how we can manage our assets as code within the repo itself. So with that, I don't think there's anything else I needed to show. We'll have some time for Q&A as well. So I think I can pass it back to Beto to show that portion now.
All right, share my screen again. Yeah, so as Srisham showed, he ran the command, we took all those models, created them in the Superset workspace, in the preset workspace, and he built that awesome dashboard. Let me open the dashboard here. And one thing we might want to do here, so at this point, we are managing our models in source control, right? We're using DBT to define these models, how they are computed, how they're generated. And there's a lot of value in that because, you can trust the data, it's not going to change by accident. Everything is in theory should be code reviewed. So what if we want to apply these same principles of data management to the dashboard, to the charts, right? Because we don't want people changing those charts. We don't want people messing up with the dashboards. There's an easy way to do that with the CLI and Superset itself, where we can export a dashboard or a chart or basically any asset in Superset. So if I go to this dashboard here, city bike rides, I can simply come here and export that dashboard. When I do that, I'm going to get a zip file, and that zip file has not only the definition of the dashboard as a YAML file that I'm going to show in a bit, but it also has the definition for all the dependent assets. So we're going to have a definition for the dashboard, but also for every chart inside the dashboard, for every data set that is used in those charts, and then for every database that those data sets are stored in. So I can show this quickly. If I click export, I get this zip file, and let me show this real quick. So we get the zip file, and inside we have, like I said, data sets, databases, dashboards, and charts. Each one of this is a YAML file, but it's readable, and we can add this to source control. So what I did here is, in our preset DBT demo repo that has our DBT models, our DBT project, I created this directory assets, and I basically added the datasets, the dashboards, and the charts here. So we only have one dashboard, but as we saw, that dashboard is composed of many charts, and those charts, they're reading from datasets in 2 different databases, the DBT one, and there's Snowflake, which is basically the same one that we're using for DBT. So we can take those files and commit them to either to a separate GitHub repo, or in this case, I did to the same repo. So let's say we want to manage everything together. So this is how the dashboard looks like. Now we have a dashboard title, there's a description, there's some metadata here that describes every chart and its position, and which is like the bulk of the dashboard is basically the position of all the charts, right? That's what a dashboard is. If we look at charts, we can see that charts have a name, they have a visualization type, and some parameters that are passed. They have metrics defined on them, and so on. So let's say we want to play with this. So we've added that to source control, and let's say we want to change the title of the dashboard here. So we can just edit this file. So this is the YAML file for the dashboard. Like I said, everything now is in source control. So we can create a PR, we can have somebody review this. And then if we want to push this to the dashboard, all we need to do is, we zoom in here. So we have, just like we had the sync dbt command, we have a sync native command. The sync native command has that name because instead of reading DBT files, right, the sync dbt command, it will read both the manifest and also your DBT profiles to get the database connectivity information. The sync native will read the YAML files that are the native export from Superset. That's why we were able to export the dashboard, add those files unzipped to the repo, and then I'm here in the directory where we have our charts, dashboards, and datasets. So basically you run the command, we specify the directory where our assets are, and then I need to specify that I do want to overwrite the existing assets if they're there. Once we do that, we can see the workspace where this is being applied. One thing I mentioned earlier is if you don't specify the workspace, you get this list of workspaces that you want to publish to. And let me find the right one here. Srini, okay, 49. So if I just type 49 here, of course I have like 58 workspaces because I work for Preset. I think most people have just a handful, but you can specify interactively. You can specify multiple workspaces if you want. And then if you go back to our dashboard, the title should have changed. Yeah, so we can see the title has changed, and we can change like many attributes. We can change the status of if it's published. The cool thing about this process is that it supports Janja. So one of the things I mentioned is when you run all these commands, either the dbt sync or the native sync, you can specify multiple workspaces. That doesn't make a lot of sense because there's not many reasons why you want the same dashboard in different workspaces if it's identical. Maybe you have some some users that have access to one, some users that have access to other, and then it would make sense. But one thing you can do is you can add Janja templating here. And that Janja template can be aware of the workspace, can be aware of many things, so that you can have one file with templating that when pushed to different workspaces will have like different configurations. So you could do this at the database level so that each workspace will actually point to a different database. You could have one workspace pointing to your dev environment, your dev database, and another workspace pointing to your production database. So you could just template that, which database you're reading from, and then you push to these two workspaces and they will show the same charts, the same dashboards, but for different underlying data. Or if you have, maybe you have multiple workspaces, let's say you manage a lot of warehouses, each warehouse has a workspace where people can track any relevant data for them, their sales, their inventory. So you could also like picture yourself pushing the same charts to all of these workspaces, but in each workspace, it will read only data for that particular warehouse. And again, we're extending that model where with dbt, we can manage data under source control because we don't want it to change. We want it to be reliable and certified. And we're going one level up, and now we have charts and dashboards that are also certified. They're built with source control, and they're not meant for users to change. So there's an option that you can toggle that will make those charts read-only. Let me switch this back. I don't want to mess with this nice dashboard. And then I do this. Yeah, we have, if you want to learn more about this, we have a blog post talking about how to manage these assets with source control, how to apply templating. You can define your own custom functions in Python. You can do a lot. It's very powerful.
I think that mostly about wraps up most of the stuff we were going to talk about. So if anyone has questions for us, happy to take some time now to answer that.
Yeah, I saw there's a question about planning for building automation. So one thing we do, we have blog posts on dbt and like managing the native assets is we provide GitHub Actions that you can use. So like for dbt, if you change your model, once you commit, it pushes to the workspace all the changes, and the same thing for these assets. So if you have a repo managing your dashboards, your charts, you can have a GitHub action that once something is merged to master, it will update the workspace. And for this works for dbt core. I'm working on syncing with dbt cloud. So if you're using dbt cloud, we want to build the same process, but instead of reading from your manifest, we're simply going to talk to the dbt cloud APIs and get the data. Pushing back changes is a bit more complicated. Like automating the exposures, I think it's a bit more complicated because like the dbt automation we show, if you change your dbt repo, it pushes to preset. But then if new exposures are generated, you need to modify the exposures in the repo. You need to commit that. That's a bit more complicated. I don't think we covered that use case. Oh, I think I should have clicked enter. Could you use a superset sync native command for the initial export of the YAML file? Or do you need to manually export the YAML file first? Yeah, you don't need to manually export the YAML file first. There is a command to export, so you don't need to do it manually. Or, I mean, you could, yeah, the reason we did the manual export is just it's easier because you can build the dashboard visually and then you export and you have the files. But in theory, you could, I don't know, build the file manually. I don't know if I understood the question actually.
Yeah, if you're talking about the exposures.yaml file itself, you do not. I actually had that same question when I first started with this. You don't have to manually create the exposures YAML file. That will be created via this command, all of the work that Beto has done. If you already have a dbt project set up correctly, I don't believe you need to export anything else manually on your part. All of those YAML files would have been in place for that functioning sort of dbt project to be up and running.
Yeah, Frederick, let me know if that answered your question. If not, I'm happy to elaborate more.
And oh, Pernas, I saw all of those. So I was actually answering a bunch of questions while Beto was speaking rather than answering those live. So those questions you can probably go back and see the answers to. I think the questions for Beto are a little more technical, so they would be better explained than anything else.
Okay, are you planning build automation? Okay, this is done. Sorry if you already talked about it, but how can we display the DBT table column documentation in the preset? Right now, we push description. I don't know if we have I think I have an example here. Let me see if I can find it. If you have I don't think your example, Srisham, had description.
They did not. They didn't have
Yeah, I think I have the Jaffle shop with descriptions. I can show how it looks. Yeah, so let me share my screen. So if you have a description, let me zoom in a little bit. So these are my DBT tables, and you can see here it says this table is produced by DBT, so it's certified. And then we show the description here as this little info box. I think
the column definitions that like come from the schema.yaml file, that's I think what the question was around, because you can make a comment about what the column represents in a schema YAML file. So I think the question is around whether or not those show up on the preset data sets.
Yeah, I think so. Like this description here. So this is in the schema.yaml. We can see there's a description. And then it shows up here as this little tooltip. And of course, if you edit the data set, it should be here also. Yeah, in case it's bigger, you can see it here. And then this is kind of a behind the curtain look, but we add some extra metadata here. So what is the resource type? What is the ID? What are the dependencies? And some certification details. So this is what we use to build the exposures.
Yeah.
Oh, but for columns. Okay, thanks, David. I don't think we do for columns. We could do that. It should be easy, actually.
That's pretty clever. I haven't seen people use scripts to sort of generate schemas like that. That's a cool use case on DBT there.
Yeah. I'll add a to do, because yeah, if you have the metadata in the columns in the schema, then it's super easy to push for columns. And yeah, David, I'll work on that. I'll create a ticket if you want to check out the CLI. If you want to contribute also, or just create an issue there and I'll work on it.
It's always nice to get the perspective of the people who would be using it, because it's easy for those little things to like slip when it comes to like creating these things.
Yeah, I just never saw an example that had description in columns.
The tutorial project doesn't do that. And to be fair, the demo I put together, I wasn't going like very deep into the whole like robustness or the configuration there.
Yeah. And one thing we didn't show, but it's possible, I mentioned briefly, is in the CLI, you can add a flag that will mark all those assets, the data sets, the dashboards, the charts, everything. It will mark them as read-only. And then it will say, oh, you can't edit this because this is managed externally. And we have the metadata pointing to the DBT like web server with the documentation. So currently we don't show this, but in the future I want to have, if a data set is managed by DBT, there's going to be a link that you can click and then you go to the DBT page where you can see all the information about that data set. The data is there, but it's not surfaced yet. Will this integration ever be available with professional tier customers? I don't know if Srini or Srisham can answer this better. Like right now, we only provide the API token for enterprise. I think we're planning to relax that, but that's...
Yeah, I'm not entirely sure. I know that for professional, it's like a custom quote. So professional sometimes, not professional, or enterprise sounds scary sometimes, but it's not necessarily so. So you can contact sales and they can give you a quote if you just wanted to use it. I think for now it is only in enterprise.
Yeah.
There's no current plans to relax that, but definitely we'll let you know if that changes.
Thank you all for participating.
Yeah, of course. You're welcome to the last question we just got there. It's great presenting. It was great working with Beto to do this too. And feel free to reach out if you have any questions. I'll just type my email in, just preset.io if you wanted to just talk about anything that we covered today.
Yeah, and if you're using the CLI and if there are any problems, if there's something unexpected, feel free to file tickets. And right now, I think one issue that Trishan found while working on the demo is we didn't have support for Snowflake, because the CLI will parse your DBT profiles to extract the database information so you can create the database in Superset. Right now that works for BigQuery, Snowflake, and Postgres, Redshift. But it's really easy to add new databases. So if you're using something else, you can just create a ticket and I'll add things. Yeah, we're super excited about this because, like I said, it's a really nice foundation to start looking at data using DBT and having those certified models in Superset. It's really powerful, and knowing you can trust the data, and knowing nobody's going to delete that by mistake. And I'm also excited about the metrics. Yeah, I saw Frederick's answer. But like, I'm really excited about what DBT is doing with metrics. We surface that in Superset. You can explore those metrics in the chart view in Superset. So you can apply different time grains, group by and filter any dimensions. That we're really looking forward to see where DBT is going to take their metrics layer and work with them to make sure you can use it in Superset.
Okay, I guess if we don't have any more, we can call it. But yeah, you have all of our contact information. Oh, do you maintain a collection of GitHub Actions?
We don't. In the blog post, I just share them in the blog post. But yeah, the next step is to have them in the repo so that it's easier to reuse them. That's something I'm working on. That's a great question. I love GitHub Actions. I think they're so powerful, and like it's the fact that it's free. You can spin up machines for free and install software and then run whatever you want. I think it's amazing. Like I'm a big fan. And the composability, right? Like if you publish your GitHub Actions, you can just reuse them in other actions. It's really cool.
All right, then. Looks like it's a wrap.
Cool.
Thank you all.
Thank you.